Today's objective is the rules of exponents. And these are the basic rules. We'll have some more involved rules in another video. So remember, exponents tell you how many times to multiply the base. For example, 2 to the 4th, the exponent 4 tells you to write down the base 2 4 times and multiply it together. However, if we have x to the 3rd, we can write the x down 3 times, but we can't multiply them together because we don't know what the value is. So that's all we can do. Now we can multiply exponents with the same base. We can multiply powers, I really should say, that have the same base. So 2 to the 4th times 2 to the 3rd can be written as 2 to the 4th is 2 times 2 times 2 times 2 times 2 to the 3rd, which is 2 times 2 times 2. Now you could count, how many 2's do you have? 1, 2, 3, 4, 5, 6, 7. So it equals 2 to the 7th. But this is a little bit annoying writing this all out. So a shortcut would be to add the exponents. So it's 2 to the 4 plus 3. And 4 plus 3 is 7, 2 to the 7th. Here's another example, we write it all out. 5 to the 5th times 5 to the 6th. I'm going to write the 5 down 5 times, and I'm going to write it down 6 times. Here's 5 to the 5th. Here's 5 to the 6th. If I add all my 5's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, that's 5 to the 11th. But I don't want to have to do that every time. So I can say add the exponents because the base is the same. So it's 5 to the 5 plus 6, or 5 to the 11th. So to multiply exponents with the same base, you add the exponents. I really think I should say powers that, so let's write that down. To multiply powers, let's write, oop, let me fix my pen. Powers. All right, we always just talk about them as exponents, but really it's powers. So a to the 5th times a to the 8th, 5 plus 8 is 13, a to the 13th. B to the 3rd times b to the 7th, b to the 10th. C to the 5th times c to the 10th, 5 plus 10, c to the 15th. D to the 18th times d to the 4th, 18 plus 4, 22. Your variable terms can also have coefficients. More fun. 4x to the 5th times 6x to the 3rd. These exponents have the same base, so we can add the exponents when we do that. These are the two steps. Multiply the coefficients, add the exponents with the same base. So 4 times 6 is 24, and 5 plus 3 is 8. So this equals 24x to the 8th. Here's another example. 5m to the 3rd times 8m to the 7th. We do 5 times 8 is 40, and then add the exponents. 3 plus 7 is 10, so it equals 40m to the 10th. Here's another problem. 6w squared times 3w times w to the 8th. Don't look at the answer yet. Let's look at this. Just like the w to the 8th is really 1w to the 8th, if we were adding, we would need to know that. Well, any variable without an exponent really has a 1 for the exponent. So 3w is really 3w to the 1st. So now, when I multiply my coefficients, 6 times 3 times 1 is 18, and I add my exponents, I'm going to write this in up there. So 2 plus 1 is 3 plus 8 is 11. So 18w to the 11th. Okay, so don't forget that little invisible 1. We can also have division problems with exponents. If we add the exponents in a multiplication problem, what do you think we do in a division problem? Hopefully you said subtract. And if you didn't, that's what we do. And we're always going to subtract the denominator from the numerator in these problems, okay? Later on we can do other things, but that's what we're doing today. So 7 to the 5th divided by 7 squared. Now we could write it all out. 5 7's in the numerator, 2 7's in the denominator, and then we could say, oh, when we're multiplying with fractions, any number over itself cancels out and is 1. So those cancel out, those cancel out. My denominator is now 1, and how many 7's remain in the numerator? 3. so that could be 7 to the third. Or, if we don't want to write it all out, 7 to the fifth divided by 7 squared equals 7 to the 5 minus 2, which is 7 to the third power. Here's one more to really illustrate why we don't want to write it all out. X to the 12th over x to the 5th. So I have to write 12 x's in the numerator and 5 x's in the denominator, and then anything over itself cancels out and is 1. So I can cancel out 5 sets of x's, and then I have 1, 2, 3, 4, 5, 6, 7 x's left. So x to the 12th divided by x to the 5th is x to the 7th. Or shorter, x to the 12th divided by x to the 5th equals x to the 12 minus 5, which is x to the 7th. Now, division problems can also have coefficients. Just think of them as fractions and reduce the fraction, then subtract the exponents. So 7c to the 9th divided by 21c to the 3rd can be rewritten as 7 over 21 times c to the 9th over c to the 3rd. So I've separated it out into the coefficient part and just the power part. 7 over 21 reduces to 1/3. C to the 9th over c to the 3rd is c to the 9 minus 3. And our answer is c to the 6th over 3. 9 minus the 3 is 6, but please notice we don't write 1c to the 6th over 3. The 1 is not necessary, okay? I don't want you to get in the habit of writing it. Sometimes it'll be there, but right now I don't need you to do that. Okay, here's another problem. 12n to the 5th divided by 8n squared. Separate it out. 12 over 8 times n to the 5th over n squared. 4 is a common factor of 12 and 8. It goes into 12 3 times and 8 twice. And then we rewrite this with subtraction, n to the 5 minus 2, which is 3. Well, I don't know where I got that number. 3. Let's just erase that and write it right. So the answer is 3n to the 3rd over 2. But wait, there's more. I know you're thinking, oh boy. What if you have a problem where you have to do multiplication and division? Well, simplify your numerator, simplify your denominator, then you can do the subtracting, okay? So our numerator is 3m to the 5th times m squared. So we would add those exponents and get 3m to the 7th divided by 15m to the 3rd. Now, 3 over 15 becomes 1/5. M to the 7th over m to the 3rd, m to the 7 minus 3. So 7 minus 3, we get m to the 4th. I don't carry the 1 over, and then 5 is my denominator. Here's one more like that. 12y squared times 3y to the 8th divided by 16y to the 5th. Simplify your numerator. 12 times 3 is 36. Add your exponents. 2 plus 8 is 10. So it's 36y to the 10 divided by 16y to the 5. What's the greatest common factor of 36 and 16? 4. So 4 divides into 36 9 times. It divides into 16 4 times. And then we subtract our exponents. Y to the 10 minus 5. So that's 9y to the 5 over 4. And when you feel confident with these, you can skip showing some of the middle steps, but you always need to write down the problem and the correct answer. That's it.